Hello class, we're about to start section 2.1, which is stated here in our syllabus is supposed to cover the following pages: page 112, page 115, page 116, and page 20, and also provides the numbers that we're supposed to complete. Now, on page 111, we have the start of lesson 2.1, which is follow the pattern. The learning objectives: recognize patterns and use them to make predictions. Distinguish between linear and exponential growth. Now at the bottom of this page, it has the group assignment, which you all could do in your groups at your leisure, but I'm just covering the problems that you're supposed to do in class. So now, we come here to page 112. How good are you at recognizing patterns? If you look for them, they're all around you. In some cases, there are patterns and things you see all the time, but never really thought about in terms of patterns. Two examples of visual patterns are shown here. The QR code will direct a smartphone to the website of the St. Louis Cardinals. The UPC is for a 12-pack of 7-Up. Try them if you don't believe me. They may look like a bunch of squares and lines at first glance, but there are definite patterns for the discerning eye that knows what to look for. One good way to practice recognizing patterns and anticipating where they lead is to study strings of numbers and letters. Looking for a pattern in question 1 through 8, find and describe the pattern. Then use it to make a reasonable prediction for the next 3 symbols. Okay, now we look here at number 1. We have 3, 6, 9, 12. Now, if you notice here, we're basically adding 3. So we're going to add 3. So the next would be 15, 18, 21. Now we come here to number 2. We go from 3 to 6, 6 to 12, 12 to 24. What we're doing here, we're multiplying by 2. So we're multiplying by 2. So 24 times 2 is 48, 48 times 2 is 96, and 96 times 2 is 192. Now we come here to number 3. We have 320 down to 160, 160 to 80, 80 to 40. Now if you look at these numbers, these are some large numbers. So what I will do is start with the smaller numbers. To get from 80 to 40, we have 2 options. We can subtract 40 or divide by 2, because 80 minus 40 is 40, and 80 divided by 2 is also 40. But if we look here from 160 to 80, we know subtracting 40 from 160 is not going to give us 80, but dividing 160 by 2 will. So that lets us know we will divide by 2. So then we have 40 divided by 2, which is 20, 20 divided by 2, which is 10, and 10 divided by 2 is 5. Now number 4, we go from 320 to 240, 240 to 160, and 160 to 80. Now what I would try, because there is a fractional number that you could use to get from 320 to 240, but first I would try subtraction. To go from 320 to 240, we would subtract 80. If we subtract 80 from 240, that would give us 160. Subtract 80 from 160 would give us 80. Okay, so, or we could do like we did in number 3. Take the lower 2 values. We know if we subtract 80, that would give us 80, or if we divide by 2, that would give us 80. But we know 240 divided by 2 is not 160, but 240 minus 80 is 160. So we would subtract 80. So this would give us 0, negative 80, and negative 160. Okay, now we move on to problem number 5. Now we have A, D, G, J. Now, if you look at this, if you move through the alphabet, we will have to move through the alphabet, and we would notice that it is every third letter. So if you start at A, move through the alphabet, I should have put starting with A. You move through the alphabet starting with A, so we'll start at A, and then we will go B, C, and then D. And then we will go with D, and then we will have E, F, then G, and so on. So then we will have J, then we will go to M, P, and S. Now number 6, we have 1, B, 3, D, 5, F. Now what you would notice here is these letters are in the exact position as what number they're trying to replace. So if you look at B here, B is the second letter of the alphabet, which replaces 2. D is the fourth letter of the alphabet, which replaces 4. And F is the sixth letter of the alphabet, which replaces 6. So then what we will have, we will count from 1, replacing every other number with the corresponding letter of the alphabet. So this would be 7, and then the 8th letter of the alphabet is H, and then 9. So it'd be 7H9. Now number 7. You look here, we have 1, 1, 2, 3, 5, 8, 13. Okay, now to get from 1 to 1, we're either going to add 0, multiply by 1, or divide by 1. Okay, that's one thing we could do, just the obvious operations. So we know for the second one, adding 0 would not give us 2. Dividing by 1 would not give us 2. And multiplying by 1 would not give us 2. So we have to look at a different type of pattern here. If you notice here, if we add these first two values together, 1 plus 1 is 2. If we add these next two values together, 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8, and so on. So basically, starting with 1, 1, each value is the sum of the previous two values. So then we would have to add 8 and 13, which would be 21. 13 and 21, which would be 34. 21 and 34, which would be 55. Now, we come here. We have JF, MA, MJ. And I will admit, when I first did this, I had a totally different pattern than what it actually was. But looking at this, you have JF, MA, MJ. These are the months of the year. So this is January, February, March, April, May, June. So then we know we will have July, August, and September. So it's the first letters of the months in the year. Okay, now that completes page 112. Now, we move on here to page 113. And here we will be talking about UPC codes. The familiar UPC codes that are used to find the price of an item have something called a check digit that's important in avoiding scanning errors. Obviously, it's important both to the store and the buyer that prices are entered correctly. To practice following a procedure, read the instructions below carefully, then use them to answer questions 9 and 10. UPCs are 12-digit codes. A 12-digit universal product code, UPC, code has 3 parts. The UPC for a 12-pack of 7-Up is shown on the previous page, and we have these digits here. The first 6 digits of the code, 078000, identify the manufacturer. The next 5 digits, 01180, are the item number, identifying a specific product from the manufacturer. The next 5 digits, 01180, are the item number. Oh, I read that already. Okay, the 12th digit is the check digit. When the item is scanned, the reader performs a calculation on the first 11 digits. And if the result doesn't match the check digit, the machine knows something is wrong and the scan is rejected. There's a 5-step process to calculate the check digit in a UPC. Now we have computing a UPC check digit. Step 1. We want to add all of the digits in the odd number positions. 1st, 3rd, 5th, 7th, 9th, and 11th. Second, we multiply the result from steps 1 by 3. Step 3, add the digits in the even number position. The 2nd, 4th, 6th, 8th, and 10th. Don't add the 12th digit. Add the results of step 2 and 3. The check digit is the number you have to add to the result of step 4 to get to the next multiple of 10. That is the next number that ends with a 0. Now we're going to apply this. It says check that the UPC for 7-Up provided above has the right check digit. Show all of your calculations. So let's write down the UPC for 7-Up. It's 078 3 zeros 011807. Okay, so now we are going to add up all of the odd digits. So 1, 3, 5, 7, 9, and 11 digit. So we add those up. We add 0 plus 8 plus 0 plus 0 plus 1 plus 0. And when we add that up, that gives us 9. Now this is step 1. Actually, this is step 1. Okay, step 2. We're supposed to multiply our result from step 1 by 3. So we'll multiply that by 3. That gives us 27. Now step 3. Now we're supposed to add up all of the even digits but not the 12th digit. So if we count this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we don't count this 7. So we would add this 7, this 0, this 0, this 1, and this 8. So it'd be 7 plus 0 plus 0 plus 1 plus 8. Now when we add all of this up, that gives us 16. Now step 4. Step 4, we're supposed to add the result from step 2 and step 3 together. So it'd be 27 plus 16, which is 43. Now for step 5. Now remember, for step 5, it says the check digit is the number you have to add to the result of step 4 to get to the next multiple of 10. So basically what they're asking you to do is to go up to the next number that ends in 0. So what would the next number that we go up from 43 that ends in 0 is 50. So we would take 50 minus 43, which is 7. So your check digit is supposed to be 7, which is that 12th digit that we have here. So that check digit is correct. Now you can rewind the video to see how to do this check digit. But let's go over to problem number 10. It says repeat question 9 for the UPC 885909599646 you'll be asked later to find what product the code corresponds to. So, let's go step 1. Step 1, we're supposed to add all of the odd digits. 1, 3, 5, 7, 9, 11. So that would be 8 plus 5 plus 0 plus 5 plus 9 plus 4. Now, when we add all of these up, it should give us 31. Now we go to step 2. Step 2, we're supposed to take the result from step 1 and multiply it by 3. That gives us 93. Step 3, we're supposed to add up all of the even digits except for the 12th digit. Now when we count the digits here, this is 2, 4, 6, 8, 10. It's 12 digits. So we know we would not count that last digit. So we would do 8, 9, 9, 9, and 6. So it'd be 8 plus 9 plus 9 plus 9 plus 6. Now when we add all this together, it gives us 41. Now for step 4, we add steps 2 and 3, the result from steps 2 and 3, and 93 plus 41 is 134. Now step 5, what we would do here, we ask ourselves, what is the next number that we would have to go up from 134 to get a 0 at the end, or the multiple of 10. And we know that would be 140. So we'll take 140 minus 134, and that gives us 6. So our check digit is correct. Now, number 11. It says use the internet to look up the UPC code for a product that you've bought recently. Write the UPC below and verify the check digit. Now, you could do problem number 11 at your leisure. So now we are done with the first portion of 2.1.